You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone. Thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Welcome back to the show, everyone. This is so exciting.
Hi.
Victoria's here. Oh,
I'm
so
here.
fun.
Hey.
Yay. So,
For the next 3 weeks.
I know. Yes. What a
More
what a
Victoria
season.
all the time.
All right. Great way to end through the rest of 2023. It's going to be so fun. All right. So I'm starting us off this week. I don't know about you both, but I've resigned myself to periods of just random statements as a naturalist. I realize that some things,
Tell us
statements,
more about that.
What do you mean?
like we've all been there. It's when we say something that is absolutely ridiculous, especially out of context for whatever we might be teaching, but it's necessary within context.
Right.
I mean, I'm thinking how at one of
I think
our
I'm following you. Yep.
yeah, as one of our old workplaces or one of our mutual workplaces has a board of quotes, right?
Oh, does it ever?
Yes.
Yes.
And it's funny. It's funny you should mention that, Rachel, because what we are doing at that workplace this past week was doing a lot of cleaning because we're doing some remodeling downstairs.
Oh, did
And
you
we've
find?
been finding people's heads that were
Oh, good.
photocopied and stuck in different places.
Oh, wow.
Now, I've seen these many times, and we just have left them up because they're funny.
Right.
What we didn't realize until we had to take them down was that there are quotes written on the back of them
Yeah.
from the quote board.
Yeah.
Oh,
And
nice.
there are some doozies, let me tell you.
Uh-huh.
I
Wow.
can only imagine.
We put a
So
lot of
we've been
effort.
re-enjoying those as we discover them throughout the week.
Beautiful. For our listeners, so you all know, this was done 4-5 years ago. I think it was the summer of
We left them up. We had no idea there
2018.
were quotes on the back.
We put a
Yeah.
lot of effort into those shenanigans
pretty
that year.
awesome.
It was great. So, that being said, many of my loved ones are kind of resigned to me just saying random statements sometimes, especially if I'm researching something. So, this happened to me this week
Sure.
because I'll say these things with utmost seriousness. And I did say this, we haven't covered enough mollusks. Just the sigh I received from my partner.
Yeah, I can see how out of context that would be a little like,
We were in a
What?
coffee shop.
what are you saying?
Just said that out loud. No problem. The sigh. So this week, I am actually, as
Yeah.
you might guess, talking about a lovely mollusk, a bivalve even.
You're going to cover a mollusk.
I'm going to
Uh-oh.
cover a mollusk.
Okay.
We're going to
what's
talk
a
about
mollusk?
scallops.
Oh, phew.
Okay.
Wait, hold on. Victoria, are you talking about something similar and related?
Not this week.
Interesting. Okay, so
Fascinating.
she was like partway through researching next week's episode or something, and it's like, well, I could start that over.
Ooh.
That'd be fun. But you're
Oh my
safe.
God.
You're
It's
safe.
not a
So
scallop.
Oh my gosh.
Okay.
We got close, I guess. 149 episodes. Anyway, so far. I really love scallops. My personal favorite way to eat them is you sear them and you load them up with butter and just have a little bit of pinch of pepper and think we're not talking about how to cook scallops. But I will say, trying to research, if you just
mean,
type
you
scallops,
are.
it's just, yeah, I am actually. It's making me hungry. But researching is wild.
There's
if you
very
don't
few
say
animals on this show where we just dive straight from what the animal is to how best to eat it. That's very rare on this show, I gotta say.
Thank you. I tried to be original.
I mean, unless we're playing Eat Ride Jacket.
Yeah.
Exactly, yes.
My goodness, Eat Ride Jacket.
People who are new to the show are like, what is Eat Ride Jacket? Look, people, you just gotta hang around long enough to find out.
Check out our anniversary specials. All right, so I don't want to go into recipes, but scallops are related to clams. They have that hinge shell, like that classic sort of fan-shaped shell that you find at the beach. Interestingly, scallops are only found in salt water and marine environments. They are not freshwater species. They are found in every single ocean on the planet, which is very cool, but not any freshwater, which is fun. But makes me wonder where the fan-shaped shells come from in freshwater environments, but that's a different episode. There's actually some debate to help give a little more clarity of what a scallop looks like. There's actually some debate if you think about that famous painting of Aphrodite being depicted after Aphrodite was born, the goddess. There's
emerging from the waves
emerging from the waves on a scallop shell is a debate behind it. It could
We're
be
talking
oyster,
about the Botticelli painting, right?
Yes.
Yes. Okay. Botticelli's Birth of Venus, everybody. Google it.
Thank you. So the sea scallop, there are an entire family of scallops that live throughout the ocean. One of their main predators is a starfish, which I know we've covered starfish or sea stars on the show before. And truly, I love them. I think they're really fun. And I know they're predatory, but I don't always think about them being predatory, if that makes sense.
Right.
They seem so docile.
Exactly. So the one main predator is a sea star. But what I really wanted to talk about when it came to sea scallops in particular was, so there are two really, really fun and kind of interesting facts about scallops. And one of which is that they are one of the only bivalves that are able to swim away.
Right.
They use
like jet propulsion kind of thing.
They use jet propulsion in order to swim away. So they get a little bit of water and push themselves into the open water. And they've actually been shown to migrate a little bit, which is wild. Like they'll not like super long distances, but they will migrate along the ocean floor.
Is that why they're... Oh,
wild.
Go ahead.
No, go ahead.
Yeah.
What's your question?
Is the fact that they can swim the reason that their hinge muscle is so big?
Yes. That is one of the reasons. Yes.
For the longest time, I was really confused about like what was inside a scallop. Because if you think about eating like a clam or an oyster or a mussel,
right.
The part you eat does not look anything like a scallop.
Well, you're eating a different part, actually.
You're eating a different part. It took me a longer than I would like to admit to realize that.
Yeah.
With the scallop, we're eating the muscle that closes the hinge.
Exactly. Whereas we're not doing that at all. We're eating with clams and oysters and such. We're eating another type of muscle, but it's like it's part of the filter feeding part of the oysters and stuff.
It's basically all of their body.
Yeah. Versus the scallop, it's just the one muscle.
You're playing pretty fast and loose with the term "we."
Oh, I'm sorry, Kirk. I forget that you don't eat seafood.
Yeah.
That's okay.
Kirk hates fish.
Oh,
he does. Well, fish don't exist, so.
True.
That's true. So we're all good.
All right.
And we're also bivalves are not fish.
No.
You hate things that taste fishy.
But they're seafood, yeah. I hate, anything that tastes of the sea.
Yeah.
Is it?
Nope.
We're not gonna get into this. This will become.
We don't need to go into my individual food psychoses here on the show. But,
I mean, other than the one that we all share about pineapple, but
valid.
Pineapple.
Gross. Anyway, so like Victoria was saying, the hinge muscle is what we are actually eating. And because it's so strong, that is what they are using to help propel them through the water. They're able to get a little bit of water and jet themselves away from predators such as sea stars, which is very interesting because they're one of the only bivalves that actually are able to quickly swim away. And
you don't need to go that far.
No, you really don't. Especially if they're not very quick.
It's a slow motion chase.
Or like, I mean, it's not just sea stars, like octopi and octopus and such will eat them too.
They are quicker, for sure.
Which, by the way, I was watching a video of a scallop swimming, which is disconcerting, but it looked a lot like the clams swimming in SpongeBob.
Interesting. Okay.
It kind of reminded me of that motion, except they're not like clapping closed. Now, getting back on track, because they're able to get away from a sea star, they have to be able to see the sea star in the first place. So they actually have something really interesting, which no other bivalve has. Scallops have anywhere from 10 to 100 eyes along the edges of their shell.
I had no idea.
Yeah.
I think I did know that, but I had forgotten that. It's kind of creepy.
That is so cool.
It is horrifying to see. I'm sorry. They can even...
I see you.
They can absolutely see you. And it looks like they have little pupils and everything. It's so disconcerting. They're really, really small. They are simple eyes that is just for shadow detection. So they are eyes. They're detecting changes in light around them and shadow if something comes over them, so that way they can quickly get away. But they have
And if you've got them all in a row, you can probably tell what direction it's coming from. And all
they have them
like
in
that.
2 rows, so it goes all the way along the edge of the fan of their shell. So they'll have like a row on top and they'll have a row on the bottom, like attached to some cilia and such. I'm looking at a picture right now and I'm very disconcerted.
Attached to cilia, so like they're at the end of stalks, like a snail's eyes? Is that what you're saying?
A little bit. They're also attached to like the end of like a mantle section. So like the cilia is attached to the mantle, just like just a little bit. Yeah, it is weird. Ugh. So they have like a retina to be able to allow them to produce. Oh, Victoria just saw a picture of their eyes.
I just Googled. I had been holding up until now.
So it's a good sensitivity.
Looks like an alien.
Yes, it does. And they have like they are simple eyes, but they do have retinas within those eyes to allow them as an early warning system, because it allows like the light change to get it allows them to be able to get really good contrast definition, so that way they can see changing light and patterns and motion and things.
They're blue.
I didn't mention that. On top of all of this, they're the bluest eyes.
That's so disturbing. They look like little miniature blueberries.
They're about 1 millimeter across, so they are tiny.
Oh, that's creepy.
Yeah, it's
not helped by the edge of the mantle sort of being fringed with stuff that looks like teeth, even though it's not teeth.
Right.
Yeah.
Now, does this make you want to eat scallops more or less, or doesn't affect that?
It makes me want to eat them much less. I'm going to be real honest.
Put it out of my mind.
But I generally don't think about it too much if I'm going to eat a scallop. There is that too.
Gotcha.
Yeah. So that's all I have for you both today. Pretty short and sweet on my side of things, but I have had the scallops in the eyes on my list for a while, and I thought, I think it's time.
Yeah.
So,
well, now you've gotten them off your plate.
And in my stomach, I guess. All right. So we're going to take a quick break, and when we return, it'll be Victoria.
Hey, we're back. Every so often, we will hear a sad tale in the media about someone who was killed or injured by an alligator, usually in Florida.
I was just there. I held an alligator.
Yes,
was a baby.
Small one, though.
Yeah,
a
it was a
baby.
baby.
Was it so cute?
It was really cute, actually.
Well, there are about 6 to 8 unprovoked attacks in the U.S. each year by alligators, and a death on average every 3 to 4 years. And invariably, the person has gotten too close to the water, maybe with a small dog on a leash, possibly near a pond at a housing development or on a golf course, something like that. You know, this is the scenario. Obviously, this is also a problem in places that are home to the alligator's cousin, the crocodile. For example, in northern Australia, there are about 3 or 4 attacks per year and a fatality every other year, thanks to the fearsome saltwater crocodile that lives there.
Yikes.
Similarly, in Australia, northern Australia, you want to stay away from water bodies that might be home to crocodiles. But, you know, similar to most Floridians, Australians in crocodile-infested areas know how to be very cautious about approaching bodies of water that might contain crocs, such as, again,
Sure.
golf course water hazards, an apt term. But I am actually not going to be talking mainly about alligators or crocodiles today. I'm going to be talking about another golf course water hazard predator.
Okay.
This is so convoluted.
Yes.
I have questions.
A very unexpected predator that made a home in a golf course in Queensland in the northern part of Australia. For 17 years, the freshwater lake on Carbrook Golf Course near Brisbane was home to 6 bull sharks.
Absolutely not.
Yes.
Wow.
Nice. I love sharks. We all know I love sharks. Absolutely
And Australia.
not. And Australia. Absolutely not.
Bull sharks are aptly named. Put it that way.
Yeah, when I saw this item, I was quite surprised because I was under the impression that sharks were only found in oceans, but it turns out I was wrong.
Nope.
Yeah.
There are several shark species that can survive in brackish or freshwater environments, including the Ganges river shark, which is a true freshwater shark that makes its permanent home in rivers. There's other species in the same genus that live in Australia and Papua New Guinea that are known for living like in estuaries and can get up rivers and other brackish areas and marine areas near the coast. But so is the bull shark.
Yep.
And while these Glyphus genus that I was mentioning earlier are relatively localized either to South Asia or Australia, the bull shark, which is Latin name Carcarinus lucus.
Oh man.
Yeah. Oh boy. Yeah. Carcarinus lucus, we're going to go with that, has a worldwide distribution and is quite dangerous. It's territorial, aggressive to any kind of provocation, and they're found in coastal and river areas where, there are also a lot of humans. Hey.
Yep.
So along with the great white shark and tiger sharks, it is one of the 3 species that is most responsible for human attacks.
Absolutely.
So how did these bull sharks get to the golf course lake?
Yeah, how did they
That's
get
a
to the
great
lake?
question, Victoria.
Actually,
how did they get to the lake?
In 1996, there were tremendous floods in the area.
Floods.
There it
is.
is.
Yes.
Floods. And these 6 young sharks were swept by the floodwaters into the Carbrook Golf Course Lake, which was near a river, but not normally corresponding with the river.
Okay, that was question number 2.
Yeah. And of course, when the flood dropped, the sharks were stuck there.
Stuck there, yeah.
Like, well, I guess we live here now.
Yep. Then between 1996 and 2013, there were no major floods in the area. So the sharks were completely isolated in this lake for 17 years. 17.
What were they eating?
Fish?
How big is this
There
lake?
were a lot. It's a pretty big lake. There were a lot of fish.
Okay. I was
Yeah.
picturing like a golf course water hazard, like a little pond. And I'm like,
No, it was a pretty big
sharks
lake.
eat a lot of food. Okay.
Yeah.
That's a little better.
A recent paper explored the implications of this 17-year ban in a lake on what we know about bull sharks' ability to survive for extended periods of time in completely freshwater environments, which had not been documented before. There have been other cases where bull sharks were isolated, but they were in salty bodies of water that then became more salty because they started evaporating when they were, cut off from the ocean. But this was a different thing. And so I mentioned that 2013 was the next time there was a major flood. And after that 2013 flood event, the number of bull sharks in the lake was shown to be down. Whether because some escaped or some died is unknown. Nobody was tracking these sharks really.
How do you find out there's sharks? Sorry, but
the hard way, Rachel. The hard way.
Yeah. So you're at a golf course. You're by a lake, and you see a shark in the lake, and I would tell somebody, right?
Yeah.
To remove the shark, so it would go to the ocean where it's supposed to be, not in a lake.
No.
Oh, I see.
No, Rachel. No, this became a selling point for the golf course. This is Australia.
Of course.
Okay.
It's even though no sharks are any longer in the lake, it is still part of their logo. It has a little shark fin.
Amazing.
Yeah. The last time a shark was seen there was 2017. So we think they're all gone now, whether, they all died or they escaped or some combination. We don't really know. One was poached, apparently. I will leave you with this little nugget to trouble your dreams. Bull sharks have been found in the Mississippi River.
Yep. I was waiting for this one.
I was waiting for this fact too.
As far upstream as Alton, Illinois, which is basically across the river from St. Louis, which is about 1,750 river miles upstream, or 2,800 kilometers.
Let that sink in, folks. Bull sharks in the MISSI
River.
Woo.
They've also been found about 4,000 kilometers up the Amazon. However, I will say that the confirmed bull shark catch in the Mississippi was in 1937.
There it is.
And dams now prevent sharks from going very far upstream.
Right.
In that river.
Damn.
I feel like it also potentially
they'd have to
could
wait
get
at every
too cold.
lock and.
Yeah,
What'd you
just
say,
have to
Rachel?
wait. Could it get too cold for them further up north they go?
I don't know. Maybe they
Not in the summer.
Maybe they just were never observed.
I mean, the ocean can get pretty darn cold, to be clear.
Yeah, it can.
I'm just thinking of the
giant
giant lake that lives just down my road, and I want to make sure there aren't going to be sharks in my lake.
Oh, you want to know if sharks ever made it into Lake Superior?
I think you're pretty safe.
I think I'm safe too. It's real cold there.
Niagara Falls be a pretty
That's
big
a tough
barrier
one.
to get up.
Mm-hmm.
It is really remarkable, though, because, the physiological demands of living in both fresh and salt water are pretty high.
Mm-hmm.
Yeah, very different.
As a fish in fresh water, your body has a higher concentration of salt in the surrounding water. So you're always having to get rid of water in order to keep the right osmotic pressure in your body.
Yep.
And in salt water, it's the opposite. The body's concentration of salt is lower. So actually, most saltwater fish have to excrete salt because they're always drinking in seawater.
Mm-hmm.
And so, the bodies of freshwater fish or saltwater fish are adapted with all their kidney and other mechanisms to do those things efficiently. But it's really tricky to be an organism that can do both. And it's pretty remarkable that bull sharks and others like them can do that.
Yeah, it's wild.
Yeah.
Super cool.
My sources this week were an article in the New York Times, that paper that I mentioned, titled "Who's the Biggest Fish in the Pond? The Story of Bull Sharks in an Australian Golf Course Lake with Deliberations on this Species' Longevity in Low Salinity Habitats," published in the upcoming January 2024 issue of Marine and Fishery Sciences.
Cool.
Yeah.
Thanks, Victoria.
You're welcome. We're
Awesome,
going to
thanks.
we're going to take another short break. And when we come back, we'll have Kirk.
Fantastic. Hey everybody, welcome back to the show. This week I am starting my segment off with a photo of an animal that I want the two of you to look at. And I always feel a little bad about this because the listeners can't see the image and we have to tell, or have the other hosts like describe it. But in this case, fear not, because neither Rachel nor Victoria is going to have any idea what they're looking at either. Can the two of you please look at this photo and let me know what animal that is?
Okay. This is an animal?
Okay. It says step 1, 95%, and it looks sort of like the static
Kirk.
you used to get on your TV screen when.
Yeah.
It looks like
Yeah.
it
Back
looks
in the
like
day.
the lint that you take off of your lint catcher in your
Oh,
dryer.
Dryer
Oh, yeah.
lint.
Yeah, yeah,
Dryer
yeah.
lint,
Uh-huh.
yeah. Like
or a
black
little
and
bit
white
like
dryer
that
lint.
that non-woven fabric you can get grocery bags made out of or whatever. Yeah. Uh-huh.
Or like
Very
a
good too,
fabric
very good too.
softener sheet that's really
Yes,
dirty.
Yeah,
exactly.
now the
Same.
reason, I should say, the reason it looks like this is what you're looking at is an image that was 95%, which is what the 95% is that you referenced at the bottom there, 95% computer generated to basically be noise. It's using a technique called RISE, which stands for Random Image Structure Evolution. It's basically a systematic way to repeatedly create images with specific percentages of noise in them. So in this case, this image is only 5% of the original image left. And it's like little blotchy bits. So you look at it and you're like,
if I'm squinting at it now, if I squint at it,
It's
it
like
looks a little bit like male genitalia or possibly
Oh,
Loch
dear.
Ness Monster.
this
Or
is like a
like-
Rorschach test here.
That's what I was just thinking. I'm like, if I squint, it could also be like a giraffe without its head.
Yeah.
Sure. Well, I'll tell
Okay.
you what, we're gonna go up, because the idea of this is that this is part of a study to figure out, can you identify what type of animal you're looking at? And the random noise is meant to sort of simulate a dense vegetative cover. So in this case, 95% coverage, you really can't tell what the animal is. I'm going to have you go ahead and look at picture number 2. See if that's any better. And I will say in these, the random noise is not the same in each one. It's moving around and whatnot. The parts of the animal you can see are also moving around. So it's not like you're sort of building on each one. Each picture is slightly different in terms of the
not
noise.
any better.
It looks
Not any better,
the same. Although the phallicness that was perceived
that's
Is
before
gone?
is
Okay, good.
disappeared.
Yeah. The blotchiness is just shifted around. So
Yeah, this is 10% of the actual data and 90% noise. So I'm going to have you look at this one here. This is 85% noise, 15% animal. Yep, not much better, right?
no.
All right, how about we're going to go to 80%. You're now seeing 20% of this is actually data that corresponds to the original image.
I'm going to go with it's a butterfly, but I'm just guessing.
I think it's a
I could see a butterfly in that.
or maybe like a scorpion.
Ooh. I
Or
could
a
see
we're
a
gonna
scorpion.
keep going. We're gonna keep going. This next one is actually
If we
step
squint.
5. This is 75%. 75% noise. We're up to 25% now. That's actual data from the animal. Goes to show how hard this is.
Yeah.
Also, just
this
for our
looks like
listeners too,
mush.
this is grayscale, so it is white and
Sure is.
gray and pixelated. And Kirk, this still looks like the inside of your dryer catcher.
It
Yeah.
does. It
Catcher.
does. I'm sorry. This one now is 70% noise, but that means 30% of the information on this picture is actually from the animal. Are we making anything out?
No.
Is it maybe a flying squirrel? But that might be noise.
Right.
I mean, I'm seeing maybe a little bit more of a longer curve type thing. that I hadn't seen before.
We're going to go up higher now. Step 7, this is 65%.
It would really help if I could know, like, what order this animal belonged to.
Sure would, wouldn't it?
Yep.
Yeah.
Maybe a snake?
A snake? Okay, you're getting a snake vibe?
Maybe.
I'm seeing a curve. Maybe it's a newt. That could also be noise.
I'm gonna have you look at one more. This is step 8. It's now 60% noise, but 40% of actual data on this animal. I want to see if you're getting any closer.
I think it's a weedy sea dragon.
Ooh,
weedy
that
sea
could
dragon.
be fun.
Sea dragon. At this point, I feel
Could
like
be a
what
lobster.
we're seeing is sort of like staring at clouds.
Yeah,
And we're just seeing
totally.
what we want to see.
I fully admit that. Yes.
We're looking for the future.
We're going to go to step 9, I guess.
Oh gosh.
It reminds me of those magic eye things. Except
Yep. Well, we're moving on to step 11, which is now 65% of the original data is in this picture.
giant squid.
Nope.
I'm going with bull snake or some sort of snake. I'm getting scale vibes.
I think it is a snake.
From
it does look
step
like a snake.
All right.
10.
It took us to step 11. Now, someone did
I got
mention
that from
snake
step
earlier, but it was just sort of...
I got that at step 10.
I think you were throwing out the idea of like, well, even way earlier than that.
No,
someone
much
mentioned,
earlier
like,
than
snake,
that.
but
Yeah.
it was sort of like snake, like throwing out like a random guess at the noise, sort of.
Yeah.
But it's interesting that maybe even subconsciously, your brain was saying, there's something snake-like about this picture. You are absolutely correct. This is a picture of a snake.
Yeah.
I'm going to actually show you one more step, step 12, although this test actually originally that this came from went all the way to step 20, which is just a picture of a snake.
Right.
This last picture here, step 12, is 60% of the original data. And I feel like at this point, when you see it, you go, okay, I can definitely totally see the snake now. Do you agree?
Yeah.
Yes.
Oh, I see the curve that
University,
I actually talked about earlier too.
Yeah, that curve of the snake kind of comes and goes.
Yeah.
The two researchers were, and I apologize, I'm going to try to pronounce this the best I can, Nobayuki Kawai and Kongshen He. So hope I did some justice to those names. What they were studying is something called the snake detection theory. When the researchers had students look at the images they created, the students were able to identify the snake in the noise, and this is bad news for you guys, somewhere usually between the 6th and 8th images.
Oh,
Wow.
okay.
It took you till the 10th or 11th.
I think I
now
first
we were looking
suggested it at like step 6, but
yeah, and with that curve, you know, once you know it's a snake, you go back and be like, okay,
Yeah, you can
all right,
see
now
it.
I can see it.
Okay,
I also
yeah.
don't know how big the original images were they were showing them, if that affects that or resolution, things like that. But when they did this, when they kind of averaged out all the students, somewhere between the 6th and 8th image is kind of where they started to see it. So on the low end, that was about 30% of the snake image data was there, and students were able to pick out that it was a snake. Conversely, when it was an image of a cat, bird, or fish, on average, it took the students until the 9th or 10th image to see the animal. And the 9th image, which again is on the low side, would be 45% of the original. So it took 15% more data being present before the humans could pick out the non-snake in these images. And the researchers claim that this test supports the snake detection theory, which is that the primate brain and visual sensory system evolved to detect snakes better than other animals. Snakes are a threat to primates in ways other animals might not be, and thus the idea is that there was a selection pressure to evolve eyes in the brain in a way that would actually help to increasingly be able to detect snakes, which is a pretty fascinating idea. This study would seem to fit nicely in with other research on snakes and perception. Studies have also been done where you have a volunteer perform a task that requires their concentration. And while that is happening, you also show them photos of dangerous animals to distract them. And photos of snakes have been shown to be far more distracting to humans, which seems to indicate that our brain is keyed in on and preferentially giving special attention to snakes over other dangerous animals, like say a shark or a tiger or something like that. Now, there's also a hypothesis, albeit I don't know it can ever be proven, but it's the idea that the shushing noise we do to quiet down a baby, like shh, shh, is supposed to sound like a snake hissing. And it works to quiet babies down because the primate brain evolved to make babies quiet when they hear that noise. Presumably the ones that cry when they hear hissing got eaten and taken out of the gene pool. Again, interesting hypothesis. There's really no way to test that out, right? So it's like, I don't know, but it has been proposed as a possibility.
Well, what I've heard about shushing is that it mimics the sound of like the mother's bloodstream in the uterus. And so
that's much more likely. That was my
shushing
exact same
takes
thought.
the baby back to the womb. But
exactly.
Who knows?
Yeah, that's I'm right there with you. And on that note, the question has to be asked, does this research show what it claims? Does being able to pick out snakes earlier in these degraded images mean we evolved to be better at picking snakes out than other animals? And I'm going to give a strong maybe. So the researchers in this case clearly think so, but we always need to be looking for other explanations. And there is another explanation. Maybe snake camouflage just isn't that good, right?
Yeah.
So it is equally likely in my mind that the reason we can pick out snakes from the environment is that they are limited by the shape and composition of their body. They are composed of a long straight line, and straight lines are always easier to pick out in nature. Even if that line is curved, it's a hard edge, and hard edges stand out. Camouflage is most effective when it breaks up or hides the outline of your body. If you're a furry mammal with multiple limbs, or a bird with wings and legs and a head and all these feathers, there are opportunities to manipulate not only the color of your body, but also the shape. And fur and feathers are also able to be used to blur the edges of an animal, making it harder for our brain to separate it from the background and foreground noise. So even with good patterns, snakes are fundamentally always sharp-edged objects. They're composed of a long line, and it could just be that lines are easier to pick out than fuzzy shapes, right?
Yeah.
There's also a limitation, I think, in this study, in that it is obscuring an animal using random noise. And the researchers make a claim, which they don't back up in the paper, that this random noise is a good simulation of vegetation. And I don't buy it.
No.
I don't buy it. I've taught enough about animal camouflage as a naturalist to know that camouflage is often very specific to habitat, and not all habitats are the same. Animals have preferred vegetation types they like to hang out in that is good for their camouflage, and camouflage has evolved to mimic specific patterns and colors. And showing black and white images of animals with just a general generic noise mixed in does not replicate what occurs in nature, because animals are not hanging out in random vegetation.
No.
There is intention behind where they hide. There's intention behind how they position their body. There's intention behind how much of it they let be visible, right? These things are all not controlled for in this experiment. And camouflage is as much about behavior as it is about color and pattern. And what I think this study has actually shown is that humans can pick sharp lines out of noise better than they can pull fuzzy shapes out of noise. That certainly has implications for how well we can see snakes. But in the end, I'm just not convinced this particular study is proof of the snake detection theory. I think there's simply too many confounding factors and alternate explanations that the researchers failed to eliminate. Now, the researchers do note in their paper that humans can pick out the diamond shapes of scales very quickly, and only snakes have those shapes. And this has been shown through other research. So I guess I have to say, when I go back and look at the earlier images in the sequence, like even numbers like 3 and 4, when there's no body shape, if you know it's a snake, you can kind of go, I do notice some kind of diamond patterning,
some sort of scale looking thing,
which is interesting.
Yes.
Yeah, exactly. But fish have scales too, so I don't know. I did definitely see the diamond pattern before I saw the outline of the snake. So maybe that makes their point. I don't know. Is the snake detection theory legit? Again, maybe. it's hard to say at this point. There are lines of evidence, multiple lines of evidence that seem to indicate there may be something there. And in that sense, this study can be taken as part of an emerging pattern that seems to indicate there might be something to the theory. But as a standalone piece of evidence, I'm simply not convinced yet.
Yeah.
But you know what? That's how science works. Incremental progress and multiple lines of evidence that maybe on their own wouldn't be sufficient to convince you of a theory. But when all the lines of evidence kind of are pointing to the same place, that eventually, they point us to our best current understanding of what we think is going on. So it's kind of a cool metaphor for just how science works.
Totally. Do you happen to know what the academic background of these researchers was? Are they data scientists or are they biologists?
No. The study was funded by the Japanese Society for the Promotion of Science, which is pretty generic. It was published in PLOS One, and the I know it was also talked about on neurosciencenews.com. So they may be studying neuroscience, but it does not doesn't actually say. But they're not necessarily, they're coming at it from a different perspective than maybe someone like myself might come at it. And that brings me to actually my citation for this. Everything I had was from this actual research paper. If you want to check out all the images and read about this whole thing, it was called "Breaking Snake Camouflage: Humans Detect Snakes More Accurately Than Other Animals Under Less Discernible Visual Conditions." And I agree with that. And that is from the October 2016 issue of PLOS One.
Cool.
Thanks, Kirk.
Well,
yeah,
thanks. That
pretty
was very
weird.
Interesting.
Wild.
Yes.
To pick snakes out is pretty useful.
I mean, yeah, that's fair.
Well, if you like snakes, I hope you find some. If you don't like snakes, I hope you're able to avoid them. And thanks for tuning in for another episode.
Thank you.
See you all next week. Bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.